Good afternoon, everyone. In a few minutes, we will start the third day of the workshop mining, environmental liabilities, and secondary raw materials. We're waiting for more participants to join the meeting, okay? Hello, welcome to the third session of this workshop. I will remind you, as we explained the other days, that you can submit your question to the speaker through the chat. Don't hesitate to ask whatever you need. At the end, the speaker will have time to answer some of them depending on the available time. The sessions will be recorded and shared on our website along with the workshop presentation once the event has concluded. To receive a certificate, it's necessary to complete a test. The link to the test will be shared in the last session and also via email. Today's sessions will focus in remediation of environmental liabilities. I'm pleased to introduce today's speaker. Ignacio Zapico is CTO and co-founder of Stone 161 and assistant professor of the Complutense University of Madrid. He's a leading professional in research and knowledge transfer in applied geology. He's inventor of a patent or detecting river pollution. It's an expert also in geomorphological design using the geofluke methodology and has published in renowned international journals such as Engineering Geology and Journal of Cleaner Production. Ignacio, you can start your presentation whenever you want.
Thank you, Virginia. I would like to start saying thank you to Virginia and Gracia for inviting me to share with you all my research in case that it can be helpful for you. I hope that you are enjoying this course. I think this is a good opportunity to bring together advanced knowledge about how to deal with mining landscapes in terms of sustainability. Okay, a moment. Well, I want to start by stating something well known to all of us who work in mining, but which many people are usually unaware of. Our lifestyle completely depends on mining activity. Everything that we use daily in our daily lives comes from a mine. Even more important, the energy transition and the decarbonization of our planet are entirely dependent on the increasing demand of minerals. But the problem is that people are usually only aware of the mining activity because of its negative impacts, such as that the mining activity produces almost 30 million tons of liquid waste every year, or that the severity and frequency of tailing failures have increased since 2000. I mean, society doesn't fully understand what mining activity entails or the origins of their possessions. We need to teach them that the debate is not if mining should exist or not. The real debate is about how we can conduct mining in a sustainable way to address concerns about environmental impacts, pollution, social conflicts, and so on. And this is what I am going to talk about today. I have been conducting research projects with mining companies in Spain and Europe for over 10 years to develop truly sustainable mining practices. I have published the results in several research journals, and most importantly, I have applied them in real-world cases that I will show you later. Due to the innovation nature of these works, my university, the Complutense University of Madrid, has supported me in creating the first spin-off in the field of earth science at our university, Stone 161. Well, we develop technical projects to help companies manage erosion in their mining landscapes. We do this specifically through two of our services, Catch the Sediment and Catch the Sed, with the goal of detecting sediment pollution in natural rivers and stabilizing their tailings or waste dumps. Well, to understand why these technologies are so important, we must consider that traditional approach for restoring mining areas is based on constructing flat and straight terraces, as those that you can see in the slide. It happened all around the world. However, we also know that these landscapes are usually vulnerable to erosion, and they often develop rills and gullies. In general, a poor restoration prevents the rehabilitated area from developing sustainable ecosystem due to the low stability of the surface, represents a waste of money spent on soil and rehabilitation practices since everything is eroded, and something that many times is overlooked, that a poor restoration also contaminates because the eroded sediment usually ends in downstream natural rivers. Well, consider this example in the Alto Tajo Natural Park in Spain. In the left image, you can see the river in a natural condition, and in the right images, transported sediment from a poor mining restoration area. From a legal point of view, I want to highlight that companies responsible for those spillages can be fined up to 1 million euros. So, the big question, why does this happen? It happens because the terraces approach overlooks a universal principle. Most of Earth's surface has been shaped by the action of fluvial processes, and they organize the landscape in catchments with a main channel ending up in another channel, and hill slopes and swells managing the water through the main channel. This is the point. Natural drainage networks are removed by surface mining. So when a mining surface is developing rills or gullies, it means that cannot deal with surface runoff and it is creating a new drainage network. Have a look of this study in waste dam rehabilitation of North America. They showed that poor drainage designs were the main cause of failures in those landscapes. But this problem also occurs in tailings deposits. A recent research paper analyzing, a recent research paper published in the well-known journal Nature analyzed that from the main 8 mechanisms of tailing failures, the main 4 are related to the lack of management of surface runoff and erosion. So, in addressing this challenge of erosion of the mining landscapes, the mining industry has increasingly adopted a modern methodology such as the geomorphic rehabilitation approach. Our geomorphological restoration service is named Catch the Shape, and it is based on designing and constructing natural landscapes in areas that has been degraded by earth movement activities. Well, the main point of this methodology is to create a drainage network and rounded hill slopes adapted to the local climate and based on a local reference area with materials like waste we use in our restoration. We do these designs in CAD platforms, and some of the tools we use are the natural grade software and the GeoFlu methodology. Then, once the design has been done, we construct the designs in the field by using the same earth movement machines that we have in any mine: excavators, trucks, and bulldozers. It means that we don't need to import any special material or tools overseas. The key of this methodology is how we shape the new topography. Here you can see how a bulldozer is constructing a convex concave hill slope. Well, once the surface is reshaped according to the design, we can allow the ecosystem to evolve naturally without further intervention. In these images that you can watch, that you can see now in the slides, you can see how in the middle of the slide, the rehabilitations when we finish the work. And in the right images, you can see the geomorphic rehabilitation after 10 years of the natural ecosystems working naturally without any maintenance. Well, compared to traditional terrace method, our approach offers that it really fits in natural-based and circular economy approaches. This methodology also gets a real visual integration. It enhances biodiversity by up to 1,000%, and it reduces construction costs by almost 40%. Also, no maintenance costs are needed after the first or the second year, and since we create a stable surface for increasing the vegetation growth, we increase CO2 capture. And finally, and the most important for us, this methodology prevents erosion, contamination, and landslides due to its high stability. It means that we create real, resilient ecosystems that can evolve by themselves without any maintenance. This technology has already earned recognition from the European Union as one of the best solutions for rehabilitating mining areas. And before continuing with the samples, I would like just to do a comment about stability, because it is the main aim of this methodology is to gain stability in our rehabilitated mining area. Well, in geomorphology, when we want to evaluate if a surface is stable against erosion, we use the sediment yield parameter. It means how much sediment is eroded in an area for a year. As a reference, international laws and technical reports usually state that erosion is not supposed a problem when it is below 10 or 12 tons per hectare and year. This value is also consistent with figures reported in natural landscapes. Well, the reported values for several geomorphic rehabilitated areas, the sediment yields are always below 10, while the published figures for the rehabilitation in terraces usually exceed 100 tons per hectare and year. So when we say that it is stable, it is because it is supported by field data and research paper. Well, there are examples worldwide, and I am going to show you a few of them. Here you can see one of the most important at La Plata mine, completed by the inventor of the geoflume methodology, Nicholas Boones. As you can see, the high wall is covered with waste material, and then with the bulldozers, they reshaped the material into natural landforms, and now the landscape is stable and integrated with the surrounding landscape, natural landscape. Okay, this is another example of Nicholas in New Mexico. Here you can see the active area. It is also a coal mine, and here you can see the area restored by following this methodology, and you can see how it is totally integrated with the area. But the most important, the rehabilitated area now has a drainage network that can manage the runoff water without producing erosion exceeding the natural reference areas. This is one of the key parts of the methodology. A natural landscape produces sediment, so our rehabilitation has to produce sediment as a natural landscape. So for this reason, we copy the forms, the shapes and the processes of the natural landscapes because they are adapted to the local climate. Well, here you can see another example. This is one of my favorite ones because it was also done in the USA, and it shows how a radioactive waste storage facility was restored by managing surface runoff and preventing erosion using the same approach. I mean, in this case, the company has to do other special things to manage the radioactive waste material. But the point is that the company decided to avoid surface erosion to apply this methodology in the upper part of the rehabilitation. So now the surface can manage the water without producing an erosion that could reach the radioactivity waste material. Well, apart from the USA, this methodology has been also applied in Australia and also in Canada, but also in Spain. And now I am going to show you some few examples here in our country. In this example, you can see a metallic mine in Ciudad Real that was exploited to extract mainly lead, and zinc. This surface has been contaminating natural rivers over decades, and now we are restoring it through the geomorphic approach, in combination with other techniques to control metal pollution. This is an important point. This is not a methodology that solves all the problems that we can have in a mining area. This methodology solves the problem about how to deal with the water surface erosion. We stabilize the surface, but if the area has, as in this case, has another problem with metallic elements, we need to combine this rehabilitation with other practices to neutralize those metals. Also, if in ecological restoration projects, we also work with biologists to combine this surface with the other parts of the rehabilitation of carrying on a rehabilitation project, to introduce a new soil cover layer and also to introduce the vegetation practices. I mean, we work together with all people involved in this kind of projects. I mean, from the engineering responsible of all the rehabilitation, and from the biologists or chemists that have to apply their other methods. Well, now you are looking at the first geomorphic design carried out in Europe at Somolinos Quarry. Initially, the area was restoring using traditional approach, as shown in the top left image, which also illustrate the resulting erosion. I mean, this in the left in these images you can see a mining area restored with traditional approaches, with terraces. And since it started to develop a lot of rills and gullies, the local authorities requested us a geomorphic design and to construct it in the field. Here you can see the results after the restoration. The surface no longer experiences erosion, and one of the most important things, it has developed a complex ecosystem that evolves without any maintenance. All the evolves of the natural landscapes that you can see in the bottom images has been created naturally. We haven't spent any money on any hours of our work in doing any maintenance activity here. Now you are watching an example in the north of Sweden in an active project that I am carrying out. This project has been done by the companies LKAB and BAST. This surface was constructed as a pilot project, and due to its success, now they are applying this method in other parts of the mine. This is important. After Spain, Sweden is being the second country in Europe that it is working to applying this method in their mines. And for me, I think it is a really important achievement that a company, a very famous company as LKAB, is supporting the introduction of this methodology in the country. This pilot site is also part of an ambition monitoring project, Waste to Place, supported by the Sweden Innovation Agency, where for the 3 years we are going to monitor for the first time the erosion at the same time of the two methods of rehabilitation, the geomorphic and the terraces, by using high-resolution sensors. So next to the geomorphic rehabilitation that you can see with the green polygon, we have constructed another rehabilitation following the traditional methods. And since we want to study if the advantages and disadvantages of both methods, is being very pioneering to monitoring the two surfaces using the same technology at the same time. Well, before concluding my discussion on this technology and continue with the other one, I'd like to state that the mining industry is setting an example for other human-based activities. The geomorphic rehabilitation approach was developed in mining areas to solve stability issues, but since other sectors, such as road construction, in the case that you are looking at the screen, are facing the similar problems, they are now beginning to explore the application of this innovative technology. In short, the mining industry is becoming a model for the other industries. And I like to highlight this point because we usually say, we usually hear bad things about mining industry. And it is said that they need that people from other industry come to the mining world to teach mining people how to deal with environmental problems. But in this case, it has been the opposite. Mining is leading the application of the geomorphic approach, an approach that solves the problem of how to deal with surface erosion. And this highlights the key of applying this methodology is to create a suitable drainage network with proper natural landforms. I mean, it doesn't matter if we have a terraces in a mining area or in a road or in whatever other landscape. The problem is the same. But now, and we are experiencing that here in Spain, people from civil engineer companies or councils are coming to our mining rehabilitated areas with geomorphic approaches to learn how to apply this methodology in their contexts. So I like to highlight this achievement of the mining industry. It's an example for other industry and the society in applying the best available technologies. Here you can see another example in an urban landscapes. As you can see, the problem is the same. Urban landscapes also are facing the same problems that mining landscapes, and the solution is the same. Here, this is another example in a green area in Madrid. It is located in the Madrid Rio Park, and this park frequently experience this problem with erosion. Every time that it rains, the many surfaces areas are experience erosions in rills and gullies, and we are exploring the options to apply the same methods in these areas, introducing a natural landscapes to deal with this problem. Well, to finish with the geomorphic restoration approach developing with our service, Catch the Shape, I would like also to finish with these images that is an applying of the same methods in an old infrastructure that needs to be neutralized. So the problem is not a mining area of a road area or an infrastructures. The main point is that if an area has been has experienced earth movement activities, it needs to be stabilized, introducing drainage networks that can deal with the surface water runoff. And we have to adapt the design to the context of this area. Well, the second technology I want to share with you today is our patented service Catch the Sediment, an automatic and online system which enables users to detect, quantify, and prevent sediment pollutions in natural rivers by providing real-time data and triggering alarms in the early stages. This system is the only one of its kind globally capable of distinguishing between natural and human-created sediment, because it's based on a detailed study of the complex natural sediment processes before and after the mines. Well, assessing contamination from excessive sediment is more complex than evaluating other pollutants like heavy metals or hydrocarbons, due to natural fluctuations in sediment and flow dynamics in rivers, which vary seasonally and with river conditions. Well, for instance, these graphs show how suspended sediment concentration can vary naturally between 0 and 25 grams per liter in the Tajo River, one of the main important in Spain. But in other rivers, with very active natural erosive processes, concentrations in the river can reach even higher values. I mean, rivers naturally can carry on concentrations of 200 grams per liter, or 500 grams per liter, or more than 1,000 grams per liter. So we cannot evaluate suspended sediment contamination with a proper and adapted baseline. It is totally needed. And it is something that it is usually overlooked in mining projects. So we cannot work with a single figure to say, okay, above this level is contamination, below this level isn't contamination. No, this value vary continuously. So we need to create complex baselines to decide if a mining company is contamination related with sediment or not. Well, Catch the Sediment Service, Catch the Sediment Service is already working in a mining company in Spain, and it has been the key to avoid sediment pollution, as well as to verify that the amount of sediment producing by the company, that it is this one, 5.6, is very low in comparison with a natural gully located in the area, that it is here that you can see in green, and also is very low if we compare with another mining area without any practice of restoration at all. Well, here you can see the main steps to apply this technology. First, establishing a river baseline by analyzing sediment and flow without industrial discharge. This is the key of the method. We need to understand all the variations of every scale, and with all this data, we construct a baseline that can be compared with the spillages from our mines. Well, the second step is installing an hydrological station at the mouth of the mine that we want to monitor to gather real-time data. And third, based on the data that we are getting from our mine and our dynamic and complex baseline, we use our digital platform to monitor and receive updates on discharge, to receive updates and create alarms when needed. Well, this service, based on many research papers, apart from creating alarms, the platform also allows users to monitor in real time how much sediment is being discharged at the moment, as well as the total accumulated sediment for the year. You can see this in the right part of the images. So what I mean, I can see in every moment what is happening in my mind, and we can also see if we are getting the limit of sediment that the administration has stated for us. Also, this platform allows users to review the event history at any scale. I mean, sometimes mining companies can receive a ban or a requirement after 2 or 3 months, telling them, okay, what happened that day? So if you do this methodology, you can go over your past data to create reports, analyze in detail what has happened in your mine, and the relationship of your spillages with the natural rivers to show the administration or anyone that requests their data how what happened in that moment. Well, as I stated in the beginning, this technology has already been validated for several research papers and gained the recognition of mining industry in Spain with 2 national prizes. We have extensive experiences delivering these services across numerous projects over the past 10 years. And here are some of the clients that we have worked with, highlighting our ongoing efforts in both national and international mining restoration initiatives. So thank you very much for your attention. I have prepared the presentation for this period because I usually get many questions about this methodology since it is something very novel. So I think it can be better to have more time to discuss all the questions that you can have about the application of this methodology. So if you have any questions, I'll be happy to answer them.
Okay, Ignacio, thank you very much for your relevant presentation. It has been very interesting. If anyone has any question, you can write them in the chat. We could wait a few minutes for that. Ignacio, there is no question in the chat.
Okay.
Therefore, if you want to explain something else.
Yeah. Well, nowadays we are seeing how the administration of the projects in Europe and in America that they are requesting nature-based solution. Everything has to be based on nature-based solutions. And the point is that what I want you to take into account that applying nature-based solution is to conduct real studies about the natural processes. So my point is that we cannot apply nature-based solutions if we don't study and understand what is happening in the natural context. And all these studies need to be adapted to every project. And something very novel of this methodology is that people, when usually hear about an ecosystem, all of us understand that an ecosystem is based on plants, animals, soil. But in the past 10 or 20 years, no one used the concept of geomorphology as a part of the ecosystem. But this is the point. It's why the mining rehabilitation practices fail, because they don't consider that the shape of the landscape is also part of an ecosystem. So we can spend a lot of money in vegetation, in soils, we can have ponds to retain sediments, but this is the point. If we don't understand, if we don't introduce the concept of landform, if we don't introduce this parameter in our designs, we are going to fail with the rehabilitation. This problem occurs also in Spain, in Latin America, and in Europe. Last week, I spent some days working, visiting universities and mining companies in Chile, and they face the same problem, because the problem is that the traditional forms in terraces, you can put the best vegetation, the best soil, adapted to all the natural conditions. But why don't do the same with the landforms? And it is what this methodology solves. And also, last week I have the opportunity to see how mining companies are facing the same problems like here in Spain. Sometimes they are receiving some bans, some fines, because the administration say, okay, you are contaminating the sediment because the river, because the load of sediment is very high. But this is the point. Not only the mines produce sediment, any natural landscape produce sediment. And we need to understand how much sediment in the spillages is from the mining company and how much is from the natural landscapes. There are natural landscapes that naturally produce a lot of sediment. So, and it is not real to blame a mining company about that. In other contexts, yes, a mining company can produce high loads, but to really understand if the pollution episode is happening, we need to study this detailed baseline. Without it, any analysis that we are conducting is not realistic.
Thank you,
Yes, Virginia,
Ignacio.
do you want to say something?
Yes, several attendees have left some question for you.
Perfect, nice.
Batula Mohamed asks, I would like to ask you, what do you recommend for those of us who have just graduated in order to enter the working world related to the subject you have explained?
Well, this is a really good question. We in our university we teach the basis of these technologies, and many of the students that learn about them are students that come from science degrees. I mean, geology, biology, environmental science. I mean, they are not engineers, and mining landscapes are usually managed by engineering people. So from my point of view, the best way to enter is from the bottom. We need to be part of a mining company and understand how it works. We will have to start applying, developing environmental studies, doing more paperwork work related with permissions or whatever. But then there will be an opportunity to apply all this knowledge. But it is true, mining companies, I agree with them that people from science don't know how a mine works. So the first thing that we need to do is to really know how a mine works, because it is very complex. So this is the step. We have to start in a mining company, not doing these methods, doing another regular things. And once we are inside, we can start to spread all this knowledge in the company and look for an opportunity.
Thank you, Ignacio. Joanna Butlanska asked, is this method basically try to record geomorphology of the original terrain before mining exploitation, or adapts the mining ways to new landscape?
Well, thank you. Another really, really good question, and it is key. We try to adapt the waste material to a stable landform not to create the topography before the mining activity, because if we would do that, we will be an unstable surface, because the original surface was formed in a conditions in 100, 1,000 years where the natural processes were working on that landscapes. So my point is that we cannot create the original surface because we cannot imitate the natural processes over 100 and 1,000 of years. What we have to do, and this is one of the key parts, is we have to look next to the area a referent with materials similar of the waste material that we are going to have for the restoration. And then we copy and we analyze the processes and the forms and introduce it in the design. So to go in more straight, we don't have to create the initial topography because it could be dangerous. We have to look for another area with natural material similar to the waste material that we are going to work in our rehabilitation.
Thank you, Ignacio. Ridi Diakondua asks, I would like to know if these technologies are free to access to them.
Well, the conceptually, yeah, they are free. It's how to introduce you introduce natural landforms in your designs or study the pollutants of your mines, comparing with a baseline. The basis of these technologies are published in public papers, and if any of you wants those papers, you can write to me and I'll be happy to send them to you. But the most advanced tools to apply those methodologies are private, yes. But my point, if someone wants to learn the basics and then apply it by themselves, it is something. So we have to separate that. One thing are the concepts, the basis, geomorphic rehabilitation, suspended sediment concentration in the rivers, and another is two methods that more easily solve those problems that are private. Yeah.
Thank you, Ignacio. A minute, please. Okay, Joanna Butlanska says, are the Spanish government so with at interest in rehabilitation all mines deposit with this method? Sorry, I don't understand this. Part of Murcia is full of abandoned inactive mines.
Well, I think that there are two questions. The first one, if this methodology can be applied in active or in abandoned mines, and the answer is that in both cases. I mean, the problem is not if the area is active or abandoned. You can apply it if you are experienced rills and gully erosion. The most efficient way is to apply this methodology at the same time that the mining area is being exploited. I mean, we exploit an area and we restore with that area has finished the work. So this is the most efficient. If we do that at the same time, we save a lot of money. But then we have cases that has been eroded by the traditional approaches and are facing a lot of erosive problems. And this is true. We can also apply this method. Many companies says, oh, this method is more expensive, but it is not more expensive. For them, it is expensive because they have to rehabilitate 2 times. One with the traditional approach, it fails, and then they have to go with the machines again to remove the area. So the technical things, it doesn't matter if it is an abandoned or an active mine. But if you want to save money and avoid erosive processes from the beginning, the good thing is to do in the beginning of the mining exploitation. But of course, how we started to apply this method, for instance, here in Spain, in an abandoned area or in an old rehabilitated traditional methods area. It failed, and the authorities, not the company, decided to apply this method. But and now we connect with the other questions. If the Spanish government is trying to support this methodology, yes, there are here in Spain. We are organized in communities, and every comunidades autónomas, and each communities can decide if apply this methodology or not. And there are some of them that are applying them. I think we have examples all over Spain. But this is important. There is no a law that says that it is compulsory. It doesn't exist. But they are supporting projects that apply this methodology because the papers that we have published in international journals support that it is the best approach to solve many of the stability projects. But interesting thing is that this methodology, many companies that has applied this methodology is not because the administrations have told them that have to apply it. They have started to apply it because they realize that it is more efficient in terms of stability, in terms of reduced costs. And this is the key. People that works in the environmental area, we need to apply these solutions, showing to the mining companies figures about the costs, about the benefits, about costing the construction and the maintenance. And the mining companies have shown that it is true. That it is not only to get that administration is happy, is to get that your mining surface is stable. Yeah. But it is, I don't know if you remember in my presentation, have shown that the European Union has recognized this methodology as one of the best technology available. I mean, the European Union has a sort of documents, brief, that they are not law, but they say, based on the update acknowledge, what are the main technologies to solve problems in mining in any mining case. So if you have a problem with pollution or with stability, you can go to these documents and check what the European Union recommends. And it is true that the European Union has recommended this methodology. Another important point for those that work in Europe, this year the European Union has approved the natural restoration law. It's a key law because it's going to change the work of rehabilitation in mining areas and in other human landscapes, because this law states that more than 80% of the European Union is degraded. And this law, two important things, established that by 2050 we have to restore 90% of the European Union. And the other important thing is that all the restoration projects have to be developed following the best available technologies. So now we have a law in Europe that said that it's compulsory to restore abandoned and active projects and following the best available technologies. Now we are expecting, because we are waiting to all the countries of the European Union introduce this law in their national laws. But it's going to be a law that is going to change everything in the rehabilitation project. Yes, and I think that in a good way, because it is requesting restoration projects and the key, good restoration projects. Not everything is suitable.
Okay, Nacho, thank you. There are no further questions. Thank you again for your presentation and your vision of remediation of environmental liabilities. Thank you so much again. Thank you, everybody, for your attendance and your interest. I hope you have found today's session very, very interesting and inspiring. And we will see again tomorrow. Thank you for all. Bye-bye.
Bye.